In this video, we're going to be taking a look at the differences between implementation-defined behavior, unspecified behavior, and undefined behavior. These terms all sound similar, so it's pretty important that you understand the differences between the three early on, and I'd say this is the most important video that you will watch in the entire series. The first difference to note is that both implementation-defined behavior and unspecified behavior leave things in the standard that aren't defined. This means that it's up to the compiler vendor to define what they want it to be for that particular architecture. Undefined behavior, on the other hand, is a definition in the C++ standard that talks about program behavior when you reach a certain state. I'll now elaborate on the differences between the three. When a feature is determined to be implementation defined, this means that it is up to the compiler, the vendor, to determine what the feature will actually entail, and they must also explicitly document everything about that particular feature. One example of implementation defined behavior is something such as the size of an integer. On x86 using GCC, you'll find that an integer is 4 bytes in length, whereas on an AVR version of GCC, it's 2 bytes in length. Now, you may think, big deal, I'm only writing for x86, but if your code becomes something that you want to port to AVR, for example, you are going to have to understand that your 4 bytes are no longer 4 bytes, but 2 bytes, and this can break your code. So it's very important that you understand what is implementation defined. All right, let's move on to the more tricky unspecified behavior, which still forms a well-formed program. However, unlike its implementation defined counterpart, unspecified behavior does not need to be explicitly documented by the compiler vendor. This means that they are free to change the way they implement certain features without letting you know about this. So it's really important that you don't come to rely on unspecified behavior. An example of unspecified behavior would be a function call. Normally, people would expect a function call to pass parameters from left to right. That is, the first parameter is passed in first, the second parameter is passed in second, all the way until we reach the last parameter, which is passed in last. However, C++ doesn't define the order of parameter passing, which means that you can actually have a compiler that will pass from right to left, which is something that GCC does do, or if you have a really evil compiler, you could probably find that they may pass it in 1, 3, 5, 2, 4, 6, and so on, just odds then evens. And it really is up to the compiler vendor to decide this, but they don't have to tell you. So we will be looking at unspecified behavior and how to avoid relying on such code in this series. But it is important that you do look up features that you aren't familiar with and learn whether or not they do have some sort of unspecified behavior. All right, let's move on to the final term for this video, undefined behavior. Undefined behavior is the worst possible state a C++ program can reach. And this is because while you have written a syntactically and semantically valid program, the runtime is not guaranteed to be safe. This is where the compiler washes its hands and is not required to make any sense of what you've done. One example of undefined behavior is trying to access the 11th element of a size 10 array, or trying to double free a pointer. Okay, so one question you might be having is, why does the C++ standard have this definition for undefined behavior, which seems kind of silly? And the reason for that is because C++ checks everything at compile time. There's minimal runtime support, actually next to none, save for a handful of features. And this means that if you go and do something that the compiler can't stop you, it can't stop you. So if you go and free a pointer, and then you free a pointer again, well, the compiler is not going to know that you freed the same pointer twice, especially if you pass it into a function, and then it frees it, and then you come out of that function, and then you pass into another function, and then it gets freed there as well. So the compiler can't stop you from taking a look at that. And so what happens is, this is where it is just not going to make sense now. The compiler isn't required to do anything to stop you, and your program is likely going to do something very, very dangerous. Now, when I say dangerous, I don't mean crash. Having a program that crashes when it enters an undefined state is a great thing. It means that you know something has gone wrong. When it's bad, it means that it could silently manipulate some data, it could overwrite some files on your operating system, or if you're a part of the Defense Force, you could launch the nuclear codes. You don't want to enter an undefined state. It's bad, and we will be looking at how to avoid undefined behavior in all of our C++ programs. Okay, so in this video, we looked at the differences between implementation defined behavior, unspecified behavior, and undefined behavior. We didn't actually look at any real code in C++, and that's because understanding these terms is probably more important than understanding C++ at this point, because you need to know why these terms exist and what they mean. In the next video, we'll take a look at the differences between a definition and a declaration in C++. We will introduce a little bit of code, and then after that, we'll move on to the meat and potatoes of this season, which is C++ types.